Welcome back. So today we'll be looking on to the second part of our lecture. Now, last class we looked about functions. Today also we will look on it a little more deep. So here I'll give you an example. Okay, I'm going to give you a function here. Product is equal to factor into 2. Factor is an element of Z. Now my output I have named it as product. My input is factor and my function is factor into 2. Now I have written factor is an element of Z. The symbol I have already told you, it means element of. So what is Z? Last chapter we studied Z is the set of all integers. So I say that the factor is an element of Z. That means factors were the input. So all inputs are Z. What is Z? Integers. That means all inputs are integers. Now product is equal to factor into 2. That means all product also, all outputs are also integers, because basically input integers, if you multiply by 2, again you will only get integers, right? So let me draw these things, it will make it more easier. Okay, this is my input set. I put few numbers. Of course I cannot put all numbers because this is an infinite set, so I put few numbers. Then this is my output set. Here also I'm going to put few numbers. I cannot put all the numbers. Now let me see, if there is a relationship. And oh yes, there is. Minus 2 is 4, minus 4, 1 is 2, 5 is 10, 7 goes to 14, 2 goes to 4, 2 into 2 4, minus 6 into 2, minus 12. Nice. That is pretty nice. So these type of, so now I have shown that there is a relationship between two sets by drawing the arrows. Now till now I have been calling this thing input set, input set, input set, but this thing has a name. What is that? Domain. The input set of any function is called domain. Now what about this set? Let us look. This set is called codomain. What is codomain? Output set? No, it is not output set, it is possible output set. Why I said possible, I will tell you more specifically. Now look at this. You see that outside this thing which I have drawn, there is a number 5 here. This 5 is not connected to any number in the input set. I have not drawn, not that it is not connected, I have not drawn, right? Why? Okay, maybe why, I'm not saying why, it might be for any reason, but that is not part of the function, right? Because when I am multiplying a function by 2, I will never get 5. So there is a problem here. We know that all the outputs are in the integer set, in the set of integers. So the set of integers are my codomain. But not all set of integers, come under, will come, because all set of integers do not come here, right? Because I see that 5 is not coming. So I have to go a little more deeper into this. So this things which I put here in a circle, in a black circle, black oval, these things are the perfect output set. That perfect output set is called range. So here we have three things: domain, codomain, range. Range is perfect output set, domain is input set, and codomain is a possible output set. That means all the outputs will always be in codomain set, but the specific outputs, specifically it will become in range. Let me try to give an example. Okay, this is just an example. Suppose Raja comes with a doubt. Not a doubt, he comes with a question. He asks me, Sir, where can I find the answer of question number 246 of chapter number 57,381? So, when Raja asks me this question, I can give two answers. My one answer can be in the answer section, of course. Where can you find the answer? Of course, in the answer section. I can say that, or I can say at page number 98173649. Now, what is the specialty of this answer? This answer is really specific. That means if you go to this page, you will find the answer, no doubt. But this is not specific. Here, answer section means there are many pages in answer section book calls answer section. Many pages in answer section. I'm not telling which page you will find. I'm just telling that okay, you go to answer section, you will find. Of course, you will find. But in the second case, I'm telling him that you will find it at this specific page. This is kind of the difference between codomain and domain. The first answer, if I call it codomain, the second answer will be, I can call it range, because you should know that this page comes under the answer section only. There is no doubt. But I am being more specific when I am telling the page number. So that will be kind of the range. Okay. Some other things about functions. This is my another example. Okay, f of x. F represents function. So function of x is equal to x square. So my output is f of x and my input is x here, and my function is squaring. My input is x, my output is f of x. Now, x is an element of set. I should always say that. I should tell what x is, because x could be a rational number, x could be a whole number, or x could just be negative numbers or only positive numbers. So I should tell what my x could be, because it's a variable. So x is an element of set here. Now let me draw my diagrams. I will put some numbers in the input set. -5, 3, 4, 6, -2, blah 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 blah. Then I will square it and will put some numbers in the output set. 25, 9, 16, 36, 4. Okay. Now, if you look carefully, you'll notice something, that here I can have integers, true. But here I am having integers, but there's a specialty. All these are positive integers, because when you square a number, you will never get a negative number. I mean, of course, when you square a real number, you have not studied about imaginary numbers, so I'm not talking about that. When you square a normal number, you will never get a negative number. So I can say that my domain is set. That means my input sets are integers, but my codomain is what? My codomain is natural numbers, because they're all positive numbers, right? Since all are positive numbers, my codomain is natural numbers. I'm not put 0 here. If 0 was there, it could be whole numbers also. So now, so I can how to represent this thing. I've said about domain, codomain, how to represent all this codomain, domain and everything in one line. How to represent it will be like this. My function f starts goes from z to arrow n. F goes from z to n. This one line, all this what I said here is represented by this one line. This one line means function f has z as input set, and it is related by some function that is not given, to a set of natural numbers. with this one line I can understand that there is input set, that means domain is Z, codomain is natural numbers, and the function is f. Okay, let me move on. So what all did we see? One input can have only one output. It's a very important condition of functions. Now another thing that we need to see, that every input should also have an output. See, one input should have only one output. At the same time, every input also should have an output. That is, consider the same or all machine. So when I put something into the machine, I should get an output. If I have a machine and if I put things into the machine, and if I do not get anything outside, or if nothing comes out of the machine, what does that mean? The machine is not working. So that means the function is no longer a function, because here the machine represents a function. So remember these two things about functions, that is, one input should have one output. At the same time, every input should have an output. Okay, now relations and functions. So relations, all these things, we can represent it in two forms. We can write it in two forms. Same thing in sets, same thing like we did in sets, that is roster form and set builder form. Roster form will be like this. That is, for example, if this is my function, okay, what is this? N domain natural numbers, codomain also natural numbers, function is x plus 2. So I can either write it like this: 1 3 2 4 3 5 4 6 5 7. What does it mean? This is the domain value. If it is 1, the answer will be 3, because 1 plus 2 is 3. If input is 2, output will be 4. If input is 3, output will be 5. Input is 4, output will be 6. If input is 5, output will be 7. It goes like that. So all the first values are domain, and all the second values are codomain, or we can actually say the second values are range, because these are specific values. So all the second values are part of range. Either we can write it like this, or we could write it like this: x is x comma y, such that y is equal to x plus 2. Y output is equal to x, which is the input, plus 2. X is element of natural numbers, y is element of natural numbers. This whole thing, when I put values of x, I get like this. So this is my roster form, and this is my set builder form. The same thing like we studied in sets, the same thing, but basically I'm again saying that functions or relations, we can represent it in both these forms. So yeah, that will be it for today. In the next class we'll go to some operations that we can do in functions. Okay guys, thank you for listening. Bye bye.